Okay, Jason, so we were there in the previous lesson,
Yeah.
where we have a problem now. We have a major problem. If we bring those 2 points close together, very close together, we're going to end up with a 0 below the line. And you're not allowed to divide by a 0.
Yeah.
So now we bring in the concept of limits.
Okay.
Alright, so we're saying, let's work with the limit of h tends to 0. In other words, we're not making h 0, but we're trying to approach 0 from the left-hand side as well as the right-hand side, and we see what answer we will get from our fraction.
Okay.
We'll be looking at limits in general later on, but for now, just bear in mind that we want to get the distance between those 2 points equal to 0. We actually want the distance 0, but we cannot have the distance 0
Okay.
because then we're going to have a 0 below the line. So we introduce the concept of limit of h tends to 0. And then we have that formula. Okay.
Yeah.
And that formula is a very important formula because that formula is known as first principles.
Principle. Yeah.
Alright, and you will get questions where they ask you, please find the derivative using first principles.
Okay.
Alright, now I just need to give you a very, very important sentence. Alright, I'm going to actually write it out for you. That's how important it is. The gradient of the tangent is another word for the first derivative. Okay, do you understand what I've said there?
Yeah.
I need for you to understand that there's a correlation between the words first derivative and gradient of the tangent. It means the same thing.
Okay.
Like I said to you before, calculus is all about the gradient of the tangent. And now you can actually see it there. The gradient of the tangent is the same as asking for the first derivative. So if I'm asking you to find me the first derivative, you could find the gradient using that formula, right or wrong.
Right.
Right, so Jason, it's very important. It's very, very, very important before we proceed that you are 100% with me on this. If I ask for the first derivative, you could actually calculate the gradient for me.
Okay, yeah, I understand that.
As long as you remember that. As long as you remember that. Do not forget that. If you don't have the limit of h tends to 0, you are just working out the gradient between 2 points. You're not working with the first derivative. Remember something. If you have a graph, let's just take a normal parabola, and I'm asking you to find the tangent in that point. There's something very important about the question. The words I've just used said find the gradient in that point, or the tangent in that point. So a tangent, the definition of a tangent is that it is a straight line touching your graph in one point only. So there's a difference between the tangent and a line bisecting my graph twice. The tangent touches the graph only once. And any other line would either not touch my graph or would go through the graph twice or 3 times or however many times. But a tangent touches the graph only once. Okay?
Okay. Yeah.
And
yeah.
most of
I'm
all,
good.
in calculus, we refer to the tangent in the turning point of a graph. Most of all. Because a straight line going through the turning point of a graph, in other words, touching the graph in one point, which is the turning point, will always have a gradient equal to 0, because that's a straight line parallel to the x-axis. And that forms the basis of what you will be working with in calculus. Now bear in mind that m is the first derivative.
And the first derivative is the gradient
of
the tangents.
Of the tangent. But we would be interested most of all in where the gradient is equal to 0, in other words, where the first derivative is equal to 0, because most of the time we will be working with the turning point of a graph. Okay, it sounds all of what I'm saying right now to you, I know, probably sound very complicated and very Greek, but that's why we are recording this, so that you can go through these recordings a few times again, number one, and you can come back to this at a later stage. Because once we start working with calculus questions, what I've just told you is extremely important in understanding why you are doing what you are doing. So you could follow just the pattern, when you are working with calculus, you could just follow the pattern and do what you're told. Or you can do what you need to do because you understand what you're doing. And that's what I'm trying to lay the foundation for now. We haven't even started with calculus yet, apart from looking at the deduction of the formula for first principles. That's the only thing even remotely associated with what you're going to be doing in calculus. Alright, I've used up a lot of time now to explain a lot of foundation to you. But believe me, if you understand this foundation, calculus is as easy as falling out of a tree.
Okay.
Do you believe me?
Yeah, I'll do some questions. Yeah, no, I believe you. But I'll do some questions tonight. I'll apply the theory and see how far I get with it.
No. We're gonna be doing a question right now together. First principles question. We're gonna be doing one together, and then I'm gonna ask you to go and look at your past papers and find just the first principles questions, and you'll see how easy it is.
Okay.